In this video, we'll talk about nomenclature for ethers and epoxides. So remember that an ether is just an internal oxygen, so it has two alkyl groups on it, and then an epoxide is specifically some three-membered ring, and it can have R groups on it or not. So a lot of simple ethers are named by their common name. So for example, this guy here has two ethyl groups coming off of each side of it, so it's called diethyl ether. Alternatively, the IUPAC name would be epoxy ethane. So normally this chunk here would be the smaller part, so whatever group is smaller coming off the ether would be an alkoxy group, and then the main longer chain would be the ethane. In this case, because it's symmetrical, it's an ethoxy ethane. So if it's symmetrical, the easiest thing to do is just put a di in front of whatever the group is, and then a space in the name ether. That's the common name. Or as IUPAC style, you can do ethoxy ethane for this compound. Another example would be this guy. So we have a phenyl group on one side. Recall that just the aromatic ring coming off is a phenyl group. And then we have a methyl group on this side. So the common name would be methyl phenyl ether. So you put the two different groups in alphabetical order, and then the word ether, so methyl phenyl ether, because M comes before P. Otherwise, you could name it the IUPAC style. In this case, we've got this methoxy group here, and then we have it coming off of a benzene ring, so this would be methoxy benzene, and that is the IUPAC name. The majority of what we're going to do for ethers is just using the common name like this, and we're going to do relatively simple examples. So I'm not going to spend a ton of time having us name ethers. We use some of the simple ethers pretty commonly for solvents. If you have a very complicated ether, it's better to name with the IUPAC style because it just can be too difficult to name otherwise. But I want you to just have a basic understanding of naming of ethers. So as a substituent, if you have some OR group, that's called an alkoxy group. And so if you have, for instance, let's see, look at this. We've got an OH here, so we've got 1, 2 carbons, and then this guy is an ethoxy group. So this would be 2 ethoxy ethanol. So you've got your ethanol right here, and your OH is coming off your number 1 carbon there, and then coming off of your 2 carbon is an ethoxy group. So here, because of the alcohol, we're naming it as a substituent. So there's two different styles in naming epoxides, which are those three-membered rings. So this is the simplest epoxide I can have with only H's as substituents on my carbons. I don't have any R groups. So one way to name this is to call it an oxirane, and that tells me that I have an epoxide, and in this case I only have the epoxide, so this is just oxirane, this simple guy right here. Otherwise, I can number whatever the carbon chain is, and so this would be an ethane carbon chain. I have 2 carbons, and I have an epoxy group, so this would be 1, 2 epoxy ethane. So it's telling me that I have an epoxy group, so that three-membered cyclic ring over the 1 and 2 carbons, and then my main chain is ethane, so there are only those 2 carbons there. So in the case of more complicated epoxides, we typically use the epoxy method for naming and not the oxirane. I do want you to be familiar with what oxirane means. That should tell you that there's an epoxide somewhere, but we'll use the epoxy method for naming. So what happens here is I've got 1, 2, 3, 4, 5 total carbons, and I have an epoxide right here over the 2nd and 3rd carbons. So my main chain is a pentane, and I have a 2,3 epoxy. One more thing is going on here. I've got 2 big groups here, and then 2 H's. The H's are on the same side, the larger groups are on the same side, so this is cis with respect to that ring. There's no free rotation about the 3-membered ring, and so I need to note cis out in front. So this guy is cis 2,3 epoxy pentane. So I've got this 2,3 epoxy. That tells me that I have an epoxide stretching over the second and third carbon, so I just have that one oxygen bonded up above it to make the 3-membered ring, and that my main chain consists of 5 carbon atoms, the pentane. So if I start on one end and number to the other, I get 5 carbons. And lastly, that I have cis stereochemistry because my 2 groups are facing the same side, so they're on the same side of the ring.